Yeah. Oh, big butt. Okay. We're in Vietnam. This is crazy. You guys probably started off break, everything was nice, relaxing, just like the pictures from my trip to Vietnam a few years ago. But now that we're back, you're probably feeling a little bit like this. Shit! Talking mushrooms! Calm down. I'm calm.
Marcus is freaking out. Keep on going. What?
We're in the Coochie tunnels right now. Oh my freaking god. I am hot as. So, we just need to relax, sit back, get our notes out, follow along, and we will start doing some math and learning some math together. So we can do this. And the first lesson, it is an easier one, so let's get started. And we're going to be naming polygons. We have 3 objectives. Basically, this is kind of a vocabulary building section. And so the 3 objectives are: I can define a polygon, vertex, side, and diagonal. Next is I can name polygons by the number of sides, and I can identify convex and concave, as well as irregular and regular polygons. Okay, so let's get started. So remember, a polygon is a closed plane figure formed by 3 or more segments that intersect only at their endpoints. So that means no rounded edges, or like you can't have this in a polygon. You can't have 2 segments that like overlap each other. So here's some vocabulary. First is side. So the side is a segment. So like segment AE is a side of this polygon. The vertex is where 2 segments or sides meet. So this one has 1, 2, 3, 4, 5 vertices. And a diagonal is a segment that connects 2 non-adjacent vertices. 2 non-adjacent vertices. So from point D, there are 2 diagonals, BD and AD. This is also a diagonal. Okay? So side, vertex, and diagonal. So we can name polygons by the number of sides. And so this table shows us different numbers of sides that we can name polygons. So a polygon that has 3 sides is a triangle. We've spent a lot of time with that. 4 sides is a quadrilateral. 5 is a pentagon. So penta is, from here on out, it's a prefix and then gon. So prefix, gon, prefix, gon. So penta means 5. Hexa is 6, so like a sixagon. Hepta is for 7. Octa, like the octagon in like MMA. Nonagon is 9. Decagon, kind of like a decade, or decathlon, is 10 sides. A dodecagon is a 12-sided shape. And then anything else, like an 11-sided shape or a 37-sided shape, we would say 37 gon, or 10, or 11 gon, or 15 gon. So we would just say the number and then hyphen gon. And so one of your tasks is going to be to remember how to name these different polygons. So tell whether the figure is a polygon. If it is a polygon, name it by the number of sides. Okay, so remember, polygons have all the sides or segments, and all of the segments meet at vertices. So, yep, this works. This is a polygon. And now, since this is a polygon, it has 1, 2, 3, 4, 5, 6 sides. And a 6-sided polygon is a hexagon. Next, is this a polygon? This arrow. Well, all the sides are straight, or segments, and all the segments end in vertices. So that's great. So this is a polygon. Oh, and it's a heptagon because there are 1, 2, 3, 4, 5, 6, 7 sides. It's a strange looking polygon. We typically don't think of this as a polygon, but it falls under the definition of polygon. Right, is this crescent moon a polygon? No, it is not. It is not a polygon because it has curved sides, so the sides are not segments. So now there are different types of polygons. There are regular polygons and irregular polygons. And so it doesn't matter how many sides there are, as long as there's more than three or more. But a regular polygon is both equilateral and equiangular. So remember, that means congruent sides, and equiangular means congruent angles. So all the angles have to be the same, and all the sides have to be the same. And then if a polygon is not regular, then it has to be irregular. So there's regular, all the sides and the angles are the same or equal to each other, and in an irregular polygon, some of the sides or some of the angles might be different. All right. Lastly, we have concave and convex polygons. Most of the time, you'll be seeing convex polygons. Well, a concave polygon is if any part of a diagonal contains points in the exterior of the polygon. So if you can do a diagonal, so this vertex and this vertex, they're not adjacent to each other because there's this vertex right here. And so, or consecutive to each other. And so that diagonal goes on the outside of the shape. So therefore it is not that means it's a concave polygon. It's not a convex polygon. Another way of thinking about it is that concave polygons make caves. Like this is, I think of this kind of as like a cave or a divot while you're going around. A convex polygon is that no diagonal contains points in the exterior of the polygon. So all the diagonals made from all the vertices are within the polygon. Note that regular polygons are always convex, and most of the polygons that we look at are convex polygons. So let's take a look at this. Tell whether this polygon is regular or irregular, and tell whether it is concave or convex. So while the shape does have it's equilateral, it is not equiangular. So this is an irregular polygon, and it is convex because all of the diagonals, which are 2 of them, are within the all the diagonals are within the shape. Try my best. Woo! That was kind of bad. Well, there we go. All right, how about this one? Tell whether this is regular or irregular, and is it concave or convex? Well, while all of these are 90-degree angles, we also have some other angles as well. So we have like this one right here, which is like 270 degrees, and this one right there, and then this angle right there, and that angle right there. So it's neither equiangular and it's not equilateral because like this side length is different from this side length. So it is irregular and it is concave because we can draw a diagonal that goes on the outside. All we need is one. So irregular, concave. All right, so what about this one? Well, all the sides are the same. Oops, and all the angles are the same, so it is a regular polygon, and it is convex because, well, all regular polygons are convex, but also there are no caves involved, and all the diagonals stay inside the figure. And so that's it. We're done. Great job, and please do the online quiz and finish up.